Next speaker is Dr. Belinda Janse van Rensburg, and she's presenting on the economic important diseases of sunflower. This is probably the part that you don't want to hear, but need to hear. Belinda, the floor is yours.
Thank you so much. I want to thank you for the invitation to talk today, and it's a privilege to share some of the information with you. And I think as sunflower producers, we all need to be aware of the diseases that we can encounter in our crops, because if we know the diseases, then we can try and manage them in time. So the overview of what I'm going to talk about, the biggest problem that we have for sunflower production is sclerotinia. So we're going to talk a bit about sclerotinia. Then we're going to discuss alternaria leaf blight and also white rust. There's sclerotinia and white rust. And then I'm going to talk a little bit about seedling blight. So for a disease to develop, it is necessary for the pathogen to be present. And today, in this case, we're mainly going to talk about fungi. So the pathogen needs to be virulent, meaning it has to have the ability to infect the plant and cause disease. Then we need to have a susceptible host. And for today's presentation, that will be sunflower. Also remember that the stage of the sunflower, the age of the sunflower is important, because some diseases can infect sunflowers at an earlier stage, where other diseases will infect at a later growth stage. And then we also have to take in consideration the environment. So for each different disease or fungi we're going to discuss, have their own different environmental conditions that they need to effectively infect the plant and to spread and disseminate from the plant. So if you have all these conditions, we can have disease that develop in the plant, and it will also affect the amount of disease that develop. So if we can understand the pathogen, the environment, and the host, and maybe break one of these legs of the disease triangle, we can slow down disease or prevent disease from occurring. So now we're going to talk about sclerotinia. Now sclerotinia is a big problem for South Africa. It is caused by a fungus, Sclerotinia sclerotiorum. It causes head and stalk rot. In other countries, the stalk rot is a major concern, but for South Africa, it is mainly the head rot that we struggle with. So in this presentation, I will mainly focus on head rot. This disease is very difficult to control. It has over 500 hosts. And I mean, the crops that we plant or use to rotate, such as sunflower, soya beans, dry beans, canola, and wheat, is all susceptible to sclerotinia infections. Also, this fungi it can produce these sclerotia, and this is a hardened structure, and on the inside is compacted hyphae. And this structure can overwinter in the soil and on plant debris for up to 7 years in your field. Also, on this photo, you can see the size and the shape of the sclerotia. Sometimes it can confuse farmers or producers because it can look like sunflower seeds, and you will not be aware that it is in your sunflower seed, and maybe when you want to plant that seed again, you put that inoculum back into the soil and you make the problem much worse. So why is this fungus so successful in making our lives miserable? Because it's very clever. It has 2 infection modes or stages. So the one is the sclerotia, This sclerotia can be in the soil, on plant debris. It can lay on top of the soil. The sclerotia that is inside of the soil, when you have a plant that is growing and this hyphae can germinate from the sclerotia, and then it can go into the roots and grow systemically also into the stem or the stalk of the sunflower plant. The other method is this apophysia. So you see this is the sclerotia part, and you can see how small it is when you compare it to a paperclip here. So these sclerotia is the ones that is laying on top of the soil, and when the conditions are favorable, it will grow this mushroom-like structures called apophysia. Now it's like a disc shape, and you will find millions of spores inside each of these discs. So when conditions are favorable, you will get the spore release, and then these spores will go to the head and infect the sunflower when it is flowering. This is just the life cycle of the disease, where we have the sclerotia in the soil. Then we can have the apophysia and the release of the spores. It will go and land on the flowering part of the plant. You will have disease, and then it will produce sclerotia. And often these sclerotia fall back to the soil because of the weight of it. And then the soil gets infected again. On the other side, we can also have the sclerotia, where the hyphal growth comes out and it can infect the roots and grow up in the stalk of the plant. Again, you get sclerotia, and then it returns to the soil. Here is a photo to show you how the apophysia looks like in a field. You can see here is a single sunflower seed. So you can see how small it really is. Underneath is farmers or producers confuse this. It is a bird's nest fungus with this. So if you are not sure, you are welcome to send me photos or ask me to come to the farm. I will gladly assist you. Okay, so incidences of up to 90% have been reported in certain areas and also over certain seasons. Now remember, this disease is a seasonal disease. We get it when there is high rainfall and cool temperatures during headfall. We get the continued spread, and it is a major threat to sunflower production. I've heard of farmers that haven't planted sunflower this year just because they had so high infections last year, so they didn't want to take the risk of planting sunflowers again. Also, when we have saturated soil, it is very conducive for that apophysia production. And remember, that is the apophysia that releases the spore that infects your sunflower at flowering stage. Now, I've read a lot of articles, and most of them say that these fungal spores only infect the dead sunflower parts because they need it as a food source. Typically, you will see sclerotinia infection starting at the back of the head. It will look like a water-soaked lesion. It can be slimy. And from there on, from there on, you will see that it becomes soft, light brown and spongy. So the infection will extend into the developing head. And then also, articles say that the fungus will infect the florets in the front of the head when it's starting to dry down. So the sclerotinia will produce fibrous strands, as you can see here. This is a photo that I took in Potchefstroom, and look at the sclerotia here. It is completely growing inside the sunflower head and replacing the plant material there. This is personally the biggest sclerotia I've seen. So black sclerotia can develop below the seed layer and also around seeds. And then, as mentioned, the infected seeds will fall out due to the weight. And you will even get this scenario where the whole head can fall to the ground. And then you are making the problem worse because you are inoculating your soil with the fungus. So what can we do to manage this disease? We really need an integrated management system. There is no one control measure. So as I've mentioned, the sclerotia can survive in the soil for up to 7 years. It is therefore suggested that if we make use of crop rotation, it won't help if you rotate with like maize or sorghum or wheat for 1 or 2 or 3 years. You have to rotate for about 7 years. The other catch is if you rotate with, say, maize for 6 or 7 years, then you create other disease conditions in your field. So think carefully how you rotate and with what you rotate. It is very important to control the weeds in your field, especially the pigweed, cosmos, blackjack, khaki weed, and also volunteer plants, because they are also hosts for this fungus. And remember that head rot can still develop because wind-borne spores from the adjacent field or the other farm can blow into your field and still infect your sunflowers. We can deep bury the sclerotia, and that will stop them from producing apophysia, which releases the spores. But in the second year, if you're going to deep plow again, you're only going to bring that sclerotia back up to the soil, and then it won't benefit you at all. Then you will have the disease infection all over again. So there is some tolerance to stem and head rot that occur, but we have seen that this is mainly influenced by weather conditions. And this is why it's very important to us to screen local genotypes. And we also want to thank OPOT for funding our project in which we are screening the genotypes. Farmers can make use of desiccants to get their crops at physical maturity earlier if they see there's a problem with sclerotinia. But you really have to look at the economics of it. It must make economic sense for you as a farmer. Also, there is biological control products on the market that we can use. The one product is Conoitherium minitans, which is a fungus. So this fungus parasitizes the sclerotia. But remember, this fungus is a living organism. So it is suggested that you put it into the soil 3 months before you plant in order for it to get established in the soil. And then also a month after you have harvested, you need to apply to the soil again. So there's also cost involved in that. And at this stage, we have Contans, which is a product from Bayer, and I think they sold it to Anchor Yeast, and now I think it's difficult to be available to people on the market. Soya Grow has a product called Sclerostop, but as far as I know, it is not registered. So we're also going to try and test their products in our research trials. Also, I can't emphasize this enough. Always plant clean, disease-free sunflower seed. The next disease we are going to talk about is Alternaria. And this is caused by various Alternaria species. Previously in literature, they thought that Alternaria halianthi is responsible for the significant yield losses. Dr. Godfrey is sitting there at the back, but he did a study and he saw that Alternaria alternata is the fungus that mainly occurs on South African sunflowers. So Alternaria causes leaf blight. This is just a nice photo to show you how the spores look like under a microscope. And Alternaria will survive between sunflower crops in and on infested crop debris, on wheat host and on seed. This disease is seed-borne. So the main way of dissemination or how it is spread is through infected seeds. Now, the disease starts when the spore lands on the leaves or the stem. It can germinate then in the presence of moisture and directly penetrate and infect the leaves. Here is an example of how it looks on a sunflower leaf where the lesions have coalesced. So usually it starts with these small brown to black specks on the leaves and ranging from 0.2 to 0.5 millimeter in diameter. And then it can coalesce to form larger blighting of the leaves. If the disease is very severe, the plants can be defoliated and they can also prematurely die and lodge. This is just a photo from Godfrey that shows the Alternaria that was isolated from the sunflower seeds. So as we said, sunflower seed is the primary source of inoculum, and infection can start at flowering. The epidemic reaches the maximum intensity when the plant senescence occurs, and conditions favorable for infection is 25 degrees to 30 degrees and 12 hours of leaf wetness. So how can we control this disease? I am sure you're going to phone me in the next planting season, because you're not going to remember, but you will remember me. It is okay. So we can do some crop rotation, the destruction of plant debris and tillage operations that bury and rapidly promote residue decomposition. We can make use of resistance genotype and correct plant spacing, and a chemical seed treatment with fungicides. So now we're going to talk about white rust, and it is caused by a fungus, Albugo trachopogonus. I don't know if I pronounce it correctly with my Afrikaans accent, but here in the field you see it already. It is highly visible here, and this photo was taken in Potchefstroom. This is the back side of the leaf where you can see the white rust pustules. So this is a fungus that causes this disease. Yield losses can be very high when conditions are favorable, and infections can also occur at a very early stage. The pathogen overwinters in the soil on infected crop debris as OO spores. So a OO spore is just a spore with a small like tail, and it enables it to move in water-rich environments. So the germination will occur in the presence of free water, and those spores form and enter the leaves on the stromatal openings and will infect the plant. Then typical white rust lesions can be seen on the leaves, and the pustules will rupture and release sporangia, which can lead to secondary infections. So weather conditions that favor infection is cool, moist conditions accompanied by temperatures ranging from 30 to 25 degrees. Optimal temperatures for sporangia, and remember that is secondary infection, is cooler at 10 to 15 degrees Celsius. So let's just again look at the symptoms. You will see there the chlorotic spots on the upper leaf surface, and if you get a disease, always turn the leaf around and look at the underside of the leaf as well. This is followed by formation of white pustules below the leaf surface, beneath the chlorotic spots. And what happens in these leaves? You can see the area for photosynthesis is greatly reduced. So that will also lead to a reduction in your seed production and your yield. Management, low temperatures and absence of waterlogging can reduce the levels of inoculum. Reduce planting densities of around 30,000 plants. What happens when we plant high plant densities? You create a micro environment and maybe there's more moisture in your field, and then you increase the amount of disease that you get in your field. So we can make use of crop rotation. We can plant non-host crops. But remember, these spores can survive for more than 6 years. So it means that if we do crop rotation, do it for 5 to 6 years in order for this inoculum to get to lower levels in your field. And this is if you have a big problem with this fungus in your field. We can make use of tolerant or resistance varieties and fungicides. Although the fungicides can be very expensive, but it can be considered when you are increasing seeds. Now we are going to look at Phoma blackstem. So this is also caused by a fungal pathogen, Phoma macdonaldii. It occurs in all of the major sunflower production areas of South Africa. You can get severe infection on susceptible hybrids, and it can cause up to 100% of yield losses because your stems get weakened and they can also fall over, which can cost the farmer more money because he have to go and pick up if he can harvest something from it. So this disease is soil and seed-borne, and it is favored by wet, humid, and high temperatures. Ascospores infect the leaves, and then the infection spread to the petiole and the stem. So you can see here the leaves get infected and they can die down, and then the infection spread from there. So the petiole will then turn uniformly black, and the stem lesions will then expand to form a large, shiny black patch with definite borders. This is what you will see on the stem. If you look closely at your stem, you can be able to observe small circular fruiting bodies of the fungi, and it will look like a dew drop or a shiny droplet on the stem. So how can we manage this disease? By deep plowing to bury the plant residue, crop rotation, and here it is also very important with all plant diseases to control insects that can act as vectors. And in this case, it's very important to control thrips and stalk borers because they carry these spores on their bodies and they disseminate it in your plant and they make the infection even worse. Also, again, avoid a too dense plant stand. This was just an interesting case that I came across in Potchefstroom. We often do not talk about seedling blights. Seedling blight is very difficult to control. In the first place, it is caused by a group of fungi and even bacteria. So if you get a seedling blight in your field, please come to us so that we can plate it out and make the correct disease identification for you. Even because the next season you want to know what was present in your field when you want to plan what crop you are going to plant and how to manage your disease. So we got an inquiry of the seedling blight, and I went to the field and I got some plants. So what we got from these seedling blights was charcoal rot, or Macrophomina fasciolina, and then Sclerotium rolfsi. But I just want to show you here, you can see there's white mycelium growth on the roots. And when I dug it up, or I just pulled it, the roots stayed behind, not well-developed roots, a discoloration here. So you can clearly see something is not right there. So we plated it out, and we got these two diseases. But then I started wondering, but Sclerotium rolfsi, where did this one come from? Because remember, Sclerotium rolfsi is not the same as Sclerotinia. So I went to the adjacent fields, and a field adjacent to this one is where I had planted sunflower, but it was at a flowering stage. And I scouted in the field, and I found this. And can you see this beautiful fruiting bodies of the Sclerotium rolfsi? So this is ground nut stubble from a trial from the previous season that was left on the soil. And this fungi just flourished on it. And it then infected the sunflower that was smaller, but it did not infect the bigger sunflower. So is also, you need to take in consideration the age of the plant and the type of diseases that you can expect. So I can't emphasize it enough that you always plant certified disease-free seed. Try not to hold back your own seed. It can be contaminated, and then you're going to infect your field again. You're making the problem worse for yourself. And if you can, use good sanitation practices in your field so that we can avoid this situation where you have fungi growing that can infect your new seedlings. And thank you so much, and also to UPOT and ARC for funding.
Belinda, thank you very much for sharing information on this less popular but very important topic.